Hello and welcome to our Chapter 10 review. So far we've looked at this. Area of a 2D square. Miles was nice enough to tell us that it is length times width. And then area of a 2D triangle. Izzy was nice enough to tell us that it's half of length times width, or length times width divided by 2, which is excellent. Then we're talking about this, volume of prisms. When we do volume of prisms, volume is equal to something. Who can tell me what the volume is equal to? Perfect, it's length times width times height. Does anybody else know another way to write that exact same thing? Because the book shows it in two different ways. There's length times width times height, which is the way that I like it. This is the best way. But the book will also show it as base times height, right? But base, that is our length times width, because our base is whatever the area of either our 2D triangle or our 2D square is. And that's what our base is. So I happen to like to write it as length times width times height because it's better to break it down, because you'll see those length times width times height numbers as opposed to just seeing it in general. So let's look at some examples of length times width times height. So the first thing that we're going to do is we're going to look at a rectangular prism. So here we've got this rectangular prism. We've got a side of 22, another side of 5, and another side of 13. It doesn't matter which is your length, which is your width, which is your height. When you're doing addition or multiplication, it doesn't matter which is which because it's all in that order. So what we do here, we want to find our volume. It's length times width times height. So for example, our volume for this one would be 5 times 22 times 13. It's a rectangular prism, so we don't need to put it in half. We don't need to do anything like that. Now, when we do this, like I said, it's easiest to, you just kind of got to do it. That's really just it. So when you multiply it together, you'd find your volume for this shape is 1,430. So this was just our first example, and I just did the multiplication for us. I just used my calculator really quick to do it. But let's look at another example, and we're going to work on this one together. So we're going to talk about this. So here's this one. So we've got this. We've got our length times width times height always. Now, basically with this, it's pretty, honestly, the rectangular prisms are really, really easy to walk through. They're just super easy. So for example, my length, let's just say it's 35.5. My width, I'm going to say it's 29.8, and my height is 6.3. Now, the reason I'm bringing this up, and the reason I'm showing you this, is because this part right here is what the book, as terrible as that looked, is what the book qualifies as the base. Why do we know that's the base? How do we know that's the base? And remember, any of these sides could be the base, but how do we know something is a base or not? This particularly comes into play with triangles. So let's think about that. Does anybody know how we can identify if something's a base? And this is why I'm asking, because it's tricky. Let's see. So you know if something is a base. Ooh, Gore, let's see if you have to raise your hand normally. Okay, Gore, what do you think?
It's the bottom part.
Bottom part, that's a great idea, but anything can be the bottom part if you just tilt it. You know, like if you have a triangle, I just push it over. And like, for example, our base would be our feet. But if I push me over, now my base is my stomach. Like, it's not how it works. So there's all of that. Our base, when we have it, we have two bases, and they are parallel. They are always parallel. So this especially comes into play with triangular prisms. But any prism, our bases have to be parallel, which means in our rectangular prism here, any of these can be the base. So for example, this one right here is parallel to this side. This part right here is parallel to that part. And this part right here is parallel to this part. So any of those can be our bases. It doesn't matter. But that's why I always say length times width times height. Just length times width times height. It's much easier than thinking about bases. So as I mentioned, any of these could be our bases. I don't care about the bases of a rectangular prism because it just makes it harder if we're thinking about it as base times height. Literally, always just think about it as length times width times height. You see a rectangular prism, you're going to multiply it by length times width times height. But we will want to think about the bases for something else. So we're going to talk about that. Length times width times height. For this one, once again, I just used my calculator because I don't care right now. We get 666.4.77. And because we're doing volume, it would be meters cubed. Now, on your math test, since it's online, I can't have us enter meters cubed. So just as a good side note, instead of writing that down, you're not going to write any of the units. So on your math test, you would just write the numerical value. You would not write the units because otherwise, like, I can't make it so that you can write the units. But I want to think about this. I want to talk about this really quickly. And we're going to come back to a ton of them. We're going to do so many practice problems. But how would we find the surface area of this? How would I find the surface area? So Miles is completely correct. We have 35.5 times 29.8, 35.5 times 6.3, 6.3 times 29.5, and then we add them all together. But he's forgetting something. Who knows what he's forgetting? Let's see. Shiley, do you know what he's forgetting?
I have a question.
Oh, yes. What's your question?
Okay, wait, so on the test, are we supposed to, like...
Shiley asked a great question. She said, wait, can't I do width times height times length? And the answer is yes. It's multiplication, doesn't matter. It doesn't even matter which one we pick to be our length, width, or height. Doesn't matter. Multiplication. So, again here, Miles is almost correct. We're almost there. He's on the right track. But he's missing one part. Let's think about this. This 35.5 times 29.8, that's this part right there. The next one, 35.5 times that 6.3, that is this part right there. And then the 29.8 times 6.3 is this part right there. Awesome. I've got 3 sides. What's my issue? What's my issue? Yes, Michelle.
You have to multiply you have to multiply each side by 2.
Yes. You have to multiply it each by 2 because there's 2 of each side. There's 2 of the tops and bottom, like, because there's 1 of each. So we would multiply this 2 times this, 2 times this, 2 times this. So the formula for when we're doing it, the formula is 2 length times height plus 2 length times width plus 2 width times height. So that's the formula that we see. So the surface area formula is surface area equals 2 times length times height plus 2 times length times width plus 2 times width times height. And you're thinking, oh my God, how am I supposed to remember all of that, right? Essentially, it's all of them have a 2, and you see each of the sides twice. That's exactly how I remember it, because it's super duper easy. So for example, we see, 2, 2, 2. And then we see our length 1, 2 times. Then we see our height 1, 2 times. And then we see our width 1, 2 times. So it's kind of like 2's of everything. It's like 2's of all of these things. So the surface area involves multiplication and addition. Volume is just multiplication. So if I was to find the surface area of this, I really don't want to, but it's going to be very, very large. So I would use my calculator and I'd find this out just because I'm lazy. So 35.5 times 29.8 gives me, this is so much, 1,057.9. I'd multiply that times 2. And for this top one right here, for my first surface area, I would get 2115.8. For my next one, I would have 2 times 6.3 times 35.5, which gives me, for this one, it would be 447.3. And then lastly, for this bottom one, 2 times 6.3 times 29.8 gives me that 375.48. Now, I want to ask you guys, this is an important thing. Oops, so I'm going to copy and paste this. This is an important thing. We already know how we multiply, but when we're adding, how do we add numbers together? How do we put them together? How do we line them up? That's what I'm asking. Hold on. So let's see. Shiley, what do you think?
Okay, so we have to line up the decimals.
Yes.
Yes.
So we exactly line up the decimals. So when we do this, when we're doing addition, and this is only with addition, we line up our decimals. When we're doing multiplication, what do we do when we're multiplying things? Who knows when we're multiplying? This was looking weird. Let's see. Again, let's see. Oh, I want to call on somebody new. Let's call on Olivia. What do we do?
So we have, for multiplication, we just line it up all to the right.
Perfect. With multiplication, regardless of what we do, we always line it up to the far right. So with addition, we line up our decimals. So I'm going to make this, I'm going to clear this just so I can see. I don't like how this is working, but I'll deal with it because whatever. Okay. Let's see. I'm going to shrink this down just so I can see the numbers I'm working with. So I've got 2, 1, 1, 5, and 8/10. I always say 0.8, but I get in trouble for that, but whatever. 4, 4, 7, and 3/10. 3, 7, 5, and 48 hundredths. And I'm just going to give myself some zeros there because it makes it easier to see. So here, I line it up. I get 8. 8 plus 4 is 12, plus 3 is 15. I drop my decimal. I carry the 1. 10, 18, 11, 12, 13, 7, 8, 9, and then 2. So I would get 2,938 and 58 hundredths. And that would be my surface area. And look, that's kind of crazy because my volume for this one was 6,664.77. So we have these really, really big numbers. And it makes sense, though, because these are really, really big numbers. They're really, really big numbers. So let's see. Let's take a look at triangular prisms. Which one's the base of this one? What's the base? So as we know, volume is equal to base times height, and we see that in a triangle, and we need to know what our base is for our triangular prisms. That's what we need to know. So let's see. Izzy, what do you think our base is?
Our base would be 14.
So it's the 14.
Sure.
And what else? Because it has to be two numbers that make up a base.
And that's height. So 17.
And 17.
5.
Or you think it's 17 or do you think it's 5?
I was just very sure about 14.
You're very sure about 14. That's excellent. Let's see. Shiley, what do you think the other one is? What's the other number?
Okay, so I'm going to say the number, and I also have another question.
Perfect. What's the number?
Okay. So for the height, I'm pretty sure
I want the base. Which one's the base? What two numbers make up the base? So Izzy's right. Our base is 14 and what else?
And 5.
Perfect. 14 and 5. And as we know, that's because our bases are parallel from one another. And those are the only two sides that are parallel. The other sides, they meet at not these 90-degree angles. It kind of looks like it when we're looking, but do you see how that's an acute angle, that's an obtuse angle, and that's an acute angle? Our bases have to be parallel. So they have to be that 14 and that 5. So that's our base, and our height is our 17. But I'll get back to that. Shiley's question was, she's having trouble identifying what the bases are. And here's the important thing. It doesn't matter. Because with our base, it's the exact same as our length times width times height. I only want us to know what our bases are. The only thing about our bases is, again, they are the sides that are parallel. So they are the sides that if you would like shoot an arrow through, or if you put a pencil through, it would stab both of them the exact same way. But with this, it doesn't matter because, again, we're just doing multiplication. So let's see. It's length times width times height is what we see. But is that it? What am I forgetting here? Hold on. Perfect. Olivia, Caesar, and Michelle all told me. You got to divide it by 2. And why am I dividing this by 2 and or multiplying it by half? Why am I doing that? Why am I doing that?
It's because it's half of a box.
Yeah, it's because it's
Cube or
a
something.
triangle. It's because it's a triangle. So whenever we deal with triangles, it's always half. Whenever we deal with those triangles, it's always half. So we want to find half of 14 times 5 times 7. Like I said, I am lazy. Be lazy, you guys, okay? Be lazy. 14 and a half. That just becomes 7. 7 times 5 times 17. At this point, you can do the whole thing. 7 times 5 is 35 times 17. We just do that math. So, for example, for this one, like I said, I'm being lazy and just using my calculator because for me it's more important that we get through this. Our volume would be 595 yards cubed. But remember, on that test, we can't put the units because it doesn't work because we're doing it in online form. So don't worry about putting units. All we would put was the numerical form. But we need to know. I have a question. Why is it cubed? Why is it cubed? Shiley, why is it cubed?
Yeah. It's cubed because it's a it's 3D.
Yes.
And 3D.
Yes, exactly, Shiley. It's cubed because it's 3D. That's how I remember it too. So here, when we have this, it's a 2D shape. And when I found my area, for example, I have my sides of x. X times x is x squared. We see that square. But if it is now a 3-dimensional shape, and I like to show you guys, like I said, with 3 dimensions, and I love variables. Variables are my favorite things. X, x, x. Here, x times x is x squared times x becomes x cubed. It's a 3-dimensional shape, so it's times 3. It's cubed, not times 3, but cubed. Now, here's the thing. You guys might ask me, oh, is there such a thing as a 4-dimensional shape? Kind of, not really. That's not necessarily important, but physically we are not able to see them. Here's another triangular prism. What 2 numbers make up our base? I want you to raise your hand and tell me what 2 numbers make up our base. So we see these 3 numbers here, and I care about 2 making up our base. Shiley, what 2 make up our base?
Okay. I don't see anything, but
Shiley says she's pretty sure it's length times width. She's half right and half wrong. The reason that she's half right is because, yeah, it can be length times width. But it doesn't matter which side is length, which side is width, which side is height. So, for example, I could say that this is length and this is width. And I'll give you a hint. That's not our base. Our base is this part right here, those 2 parts, because those are the 2 parallel parts from one another. We can also think about it. It's pretty easy. In triangular prisms, our bases are typically the triangle. Now, there are other triangles in triangular prisms, so it's not that, but we can think about it. Our bases are the triangle. Now, with triangles, we always just think 1/2. You see a triangle? Think 1/2. You see a triangle? Think 1/2. So it'd be 1/2 times, and then we have times 10, times 8, times 9, and 1/2. It's just that whole thing. The base part is this one, 10 times 8 times 1/2, because that's our base. But when we're doing multiplication, it does not matter. Just think. Rectangle, no half. Triangle, yes half. So we'd multiply it together. Yet again, I'm lazy, and I want to do this, so I'm doing. I get 5 times 8 times 9.5. 5 times 8 is 40 times 9.5. I like to break this up. I've got 40 times 9 and 40 times half and then I'm going to add them together. This is just me doing mental math. You don't have to do it like that. 40 times 9, 4 times 9 is 36, so it's 360. 40 times half is 20, which makes it 380. And let me check on my calculator. Let's see, 40 times 9.5. Yes, it is 380. Excellent. If you don't have this, then don't worry about it. Like if you can't do the mental math, don't worry. Don't do things that you can't do. Here we have a word problem. These ones I really like because you don't have to see the shape and you don't necessarily have to think about it. So we are going to break it down. A candle is in the shape of a triangular prism. You hear the word triangle, you think half. Always. Just associate triangles with half. The base has an area. So now we're talking about base. Has an area of 30 square inches. Remember, base is length times width. It already did it for us because our volume is our base times height and our base is length times width. So it's already told us what our base is. It doesn't matter. And it has a height of 6 inches. Find the volume of the candle. Once again, I am lazy. Cancel, cancel. 15 times 6, 15 times 3 is 45, so 15 times 6 is 90. So as Kyle asks, the formula for a triangle, a triangular prism, so I'm making my little 3D shape, is 1/2 length times width times height. Or if the book writes it down, 1/2 base times height. For our rectangular prisms, it is just base times height and or length times width times height. Yet again, these are the same thing. I like to do it length times width times height. For those of you who didn't get it earlier, this is the homework. The not 7 goes for 10.3, obviously because 10.4 involves 7. So these are the homeworks. It is due on Monday. The way that you submit it is through Schoology. Just like when we had our fake smile project, I made a document. You just paste the pictures in of the homework. I did a walkthrough of it on YouTube and I put the instructions in the thing. So that's how you post the homework for me. Now I want to think about this though. I've got my triangular prism. I'm going to do my best to draw it, essentially. It's actually a pretty good job. So here it has a base, base has an area of 30 square inches. So this would be my base. My base here is 30. That's the area. So the other side is 30. And my height is 6 inches. This is my height. It's just the other one that I don't know, right? Let's try to find the surface area of this then. Actually, I can't find the surface area of this then because it doesn't have the numbers. I'm going to do a different one to find the surface area. This is actually a good hint. In order to find surface area, you need to have 4 numbers. So in order to find the surface area, you need 4 numbers, at least. Okay. So here's another example. This is another triangular prism. We know it's a prism because it's got parallel bases, and we know it's triangular because, well, it's a triangle. That's not what I wanted to do. Okay. So this one, what we have here, it is not an equilateral triangle. This side is 6, this side is 6, but that side is 8.5. So I have to figure out my surface area. My surface area is going to be very, very similar, but it's a little different. They sometimes show this to you with a net. And what that means is we basically unfold the shape. Here's the side that I'm looking at right there. Then I've got one triangle here, and I'm just going to unfold the other triangle there. And then I've got 2 more of those sides. Picture this if you could hold this in your hand and put it back together. Do you see how if you put this back together, this side right here is this side right here? Like just kind of try to picture if you were holding this shape, that you could just bend down these triangles to make them into the bases and like the top and bottom, and you could fold in those sides, and it then would make this shape on the side. It's a little bit tricky to think of, so I don't like to necessarily do this. But let's break it down. I've got 2 triangles. So my triangle is 6 inches, 8.5 inches, right? I am wanting, so for this one, I can only find the volume again because once again, I just have 1, 2, 3 numbers. I'm not paying attention enough to my own work. So I only have 3 different numbers, so I could only find the volume. Like I said, you need at least those 4 numbers to find the surface area. Let's try to find one that I have surface area for. Perfect. I finally found one in my photos that I have surface area for. So I know that I can find the surface area of this one because I have 4 different numbers, 4 different ones. 6, I've got this 8.2, 12, 11.6, and I've got that 8.5. I have at least 4 different numbers because I need those. So here's my triangle. I have this side is 8.2 and my height is 6. What is the bottom side? What is this amount of my triangle? Who can tell me what that bottom part is? Let's just call it the length.
6?
Yes, it is 11.6. Excellent, because we see that down here as well. That side is that. It's the 11.6. So I have this triangle. Now, technically, if I were to draw this triangle, these are the numbers that I know. This number is 6. This number is 8.2. This number is 8.5. And this bottom number is 11.6. So just for this one triangular base, I have 4 numbers. But it's a base. I only care about 2 of them. I only care about 2 numbers for my base. Which 2 numbers do I care about for this base? Caesar says 11.6 and 8.5. Let's see. Gore, what do you think?
11.6 and 6.
He thinks 11.6 and 6. So we've got one side here. Somebody thinks 11.6 and 8.5 are the 2 numbers we care about. Somebody else thinks 11.6 and 6. Do we have anybody who's got any other things? Let's see. Shiley, what do you think?
Okay, so this is like about the homework.
Kyle, what do you think?
6 and 8.2.
So Kyle thinks it's 6 and 8.2. He thinks it's those 2. Izzy says 11.6 and 6. It is 11.6 and 6. So the way that we remember what it is, when we care about trying to find area, when we're doing that, it always forms a 90-degree angle. When we're finding area of anything, the 2 sides, our length and our width and or whatever the height, whatever you're doing, they always have to form a 90-degree angle. So when we're doing this, the 2 numbers that we care about for this are 6 and 11.6. Now, triangle, 1/2 times 6 times 11.6. But how many triangles do I have here? How many of the identical triangles do I have? Exactly, Gore. I've got 2 of them. So I'm going to multiply this also by 2. 2 times 1/2, that goes away. We don't care. We have 2 triangles. So when we're finding surface area, we don't care about that 1/2 just because we happen to have 2 triangles. So 6 times 11.6. 6 times 11 is equal to 66. 6 times 0.6 is equal to, what is that going to be? 3.6, yes. So then it would be 69 and 6/10. Once again, I'm just doing mental math. I'm doing it really quickly because I can. Don't worry about that. So that right there, so far, that's the surface area of just our triangles. So now we found our triangles, and now we need to find the surface area of each of our sides. So let's look at our sides now. This side is 12, and this is 11.6. So one of our sides is 12 times 11.6. Another side here, again, is 12, right? So we've got that height of 12. And this length is 8.2. And then lastly, this side again is 12, and this is 8.5. 12 and 8.5. The numbers that we've utilized are 6, 11.6, 12, 8.5, and 8.2 because it's a triangle that has different side lengths. So we've utilized all of these numbers. It's just in different forms. So try to think about it as if you put one shape of the triangle at a time. So 12 times 11.6. That would be this face right there. That would be that one face. And we see because the length is 11.6 and our height, whatever it is 12. So 12 times 11.6 is 139 and 2/10. 12 times 8.2, remember I'm just using my calculator, is 98.4. And 12 times 8.5 is 102. So now I've got all of these numbers. I'm finding surface area. So when I find surface area, what do I do? Kyle and Shiley are correct. I'm sure everybody knew it too. We add them all together. And yet again, when we add our numbers, when we're adding numbers, we line up our decimals. So the numbers I have are 139.2, 98.4, and 4/10, 102, and 69 and 6/10. Excellent. So I just am going to add them all together. Here, 6 plus 6 is 12. This one, 10, 18, 20, 29. I just bring down my decimal right there. Let's see, 15, 16, 17, 18, 19, 20. And then 4. So I get 409 and 2/10. I just basically added, as you can tell, this is how we do it. So my surface area for this one, my surface area is 409 and 2/10. So Shiley asked about this one. Here we have an unfolded rectangular prism. I don't know if you guys were ever young and, well, you were always young, and you decided to cut out and make a die for yourself, like a literal die. Because when I was in elementary school, that's something we did. And when you do it, you unfold it, and it makes this cross. Because if you folded it back together, it would make a rectangular prism. This one is nicely color-coded for us. So we can see exactly that this side is the exact same as this one. And even if it wasn't color-coded, we could figure it out because we know that this length is the same as this length, is the same as this length, is the same as this length. They're all 9 because they're all the exact same length. So, however, it did nicely color-code it for us. So this is 7.2 times 6, which is, so exactly, when we do this, we're going to find the area of each of these separate colors. Just like what we know, when we're finding surface area, it is 2 times length times width, 2 times length times height, 2 times width times height. We see those 2's, we see those lengths twice, we see those widths twice, we see those heights twice. That's how I always remember it. We see those 2, 2, 2, 2. We always see that. Now, what I have here is 6 times 7 and 2/10. This gives me 43 and 2/10. It's the same here because look, that side is also 7.2 and this side is 6, same as this length. This is 9 and this is 6. 9 times 6 is 54. This one is that 7.2 times 6, 43.2. Again, 9 times 6 is 54. This length is 7.2 and this length is 9. 7.2 times 9 gives us 64.8. I know that this is 9 as well, and it already told me because it's color-coded that this is 64.8. So what I've done here is I found the area, the plain old, straight old area of each of these rectangles, right? I found the area of each of these rectangles. So when I'm talking about surface area, again, I'm adding it all together. I'm doing this all together. So I want to add these together, and it's a lot easier when I do the multiplication first. So for example, I have 2 of the 64.8s. I have 2 of the 43.2s, and I have 2 of the 54s. I know this one is 108, but I can't, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 86.4, 128, 129, 129.6. Let me check if I did that correctly in my head. I love doing math in my head. Woo! Yes, I did it in my head. I love doing math in my head. It's like my favorite thing. And look, Caesar got it too. Yes. So then we would once again, now we have to add it all together. So far, we've done 1 multiplication here, 2 multiplications here, and then now some addition. And if I added these all together, plus 86.4 plus 108, who would like to tell me the answer? Yes, Kyle and Gore answered. It is 324. Exactly. So we did multiplication once. We did multiplication again, and then we did addition. So Shiley again was asking, okay, so actually I'm going to keep that there. Shiley was asking, okay, but how do you know what to multiply? How do you know what to do? So let's look at our different numbers. Here, I've got the number 6.2, or 7.2, I've got the number 9, and I've got the number 6. I don't care which is which. So I'm going to say my length is 6, my height is 7.2, and my width is 9. Does it matter which one I choose for what? No, it does not matter, exactly, because I'm doing multiplication. Even regardless what I'm doing, it does not matter. So then I simply just plug it in. So I've got 2 times 6 times 9. Then I've got 2 times 6 times 7.2. And I've got 2 times 7 point, actually I'm going to do it in the right order. 2 times 9 times 7.2. So if you noticed, all I did was I just plugged in. Boop. Do you see how I did it? I'm just drawing lines with the width because otherwise it's going to be like 17,000 lines. So for example, my height, like I said, here's my 17,000 lines that I'm going to be drawing. And then length, 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 length. All of my lines, it's like a gigantic octopus. But I see each number twice. I see each of them. I only see those 3 different numbers on this shape. So that's what I know I'm doing. It doesn't matter. What is my length? What is my width? What is my height? It does not matter. All that matters is that you have this 2 in front and that you see each number 2 times. This is with rectangular prisms, though. This is with rectangular prisms. Now, let's say I wanted to find the volume of this shape. So I want to find the volume. When you find volume, how many numbers do you care about? When you're finding volume, how many different numbers do we care about? So Caesar and Isabella and Gore are correct. We care about 3 numbers when finding volume because it's length times width times height. Isabella said maybe 4, or Izzy said also 4. That's when we care about surface area. So she's not completely wrong. We need at least 4 when we care about surface area. But let's look at this one. I have so many different numbers here. I have 4 different numbers here. But I don't know which numbers to care about. Oh my God, I'm so confused. I don't know what to do. So what numbers do I care about? Who would like to tell me the first number I care about? Raise your hand. So Kyle says 5. Perfect. I care about that 5. Exactly. What's another number that I care about here? Who can tell me? Let's see. Isabella. Izzy. What do I care about?
12?
12. I do care about 12. And then what's the last number that I care about, Gore? Let's see.
Why was I?
Hold on.
What?
I'm trying to unmute Gore.
16?
Okay, Gore, what's the last number I care about?
16.
16, exactly. Why don't I care about that 13? How do I know that I don't care about that 13 when I'm trying to find volume? How do I know that? Yes, Kyle, how do I know? Let me unmute you because I don't know if you're just going to type it or not. Why don't I care about that 13?
It's because it's on the same side as 12.
It's similar. It is because it's on the same side as 12, but Izzy's completely correct. It's because 12 and 5 make that right angle right here. Do 13 and 5 make a right angle? No. Do 13 and 16 make right angle? No. We only care for the bases about things that make right angles. So for example, The 12 and 16 make a right angle, and the 12 and 5 make a right angle. And so we only care about the shapes that make right angles. So for volume, it's a triangular prism. So it is 1/2 times 5 times 16 times 12. Whenever I'm lazy and I'm canceling things out, I always like to half my biggest number. So I get rid of that and it becomes 8 times 5 times 12. 8 times 5 is 40 times 12. 40 times 10, 40 times 2 is 480. 480 is my volume. But I want to also find the surface area of this shape too. I want to find my surface area. When I find my surface area, that is me adding all sides areas. It's me adding all the sides areas together. So, and I've got 2 of these same triangles. When I have 2 of the same triangles, it's going to be 2 times 1/2, so I don't even care. The area of that triangle is 5 times 12 because it's 12 and then 5. That's what makes my right angle. 5 times 12 is 60. So since I have those 2 of them, it's 1/2 of 60 for each of them. They're each 30, so they make a total of 60 together. Then I have 3 other sides that I care about. This first side. What are the things for this first side? What's the length and the width for this first side? Perfect, Gore is completely correct. It is 12 and 16. 12 times 16, because this time I am too lazy to do it in my head. 12 times 16 gives me 192. Let's look at my next side. It's kind of hard to see, but I've got this side right there. So what is the 2 numbers for that side? What are the 2 numbers that I care about for this side right here? Let's see. Yes, Izzy.
16 and 5.
Yes, exactly. 16 and 5 because my height is 5 and my length is 16. So whatever it is, I call it height and length. Once again, it doesn't matter what I call it. So 5 times 16 is 80. And then my last side is this bottom portion. And what are the 2 numbers that I care about there? Let's see.
I didn't raise my hand.
Yes, Gore?
16 and 13.
Exactly, 16 and 13. So for this bottom part, I care about that 16 and that 13, which 16 times 13 is 208. So now I've done so much multiplication because I multiplied all of these sides. 1, 2, 3, bottom 4, 5. So I have 5 sides. This side right here is just both of the triangles. Essentially 60 would be that 30 and that 30. It'd be that 30 and that 30. So once again, I want to add them together. When I add it together, I line up my decimal points. While none of these have a decimal, if they don't have a decimal, it's always at the end. So I'm going to give you guys a second, and I want you guys to add it together, okay? Perfect! We get 540. Thank you so much, Caesar, Gore, and Izzy. I know that other ones of you were doing it too, but that's just who we got right now. So Caesar, Gore, and Izzy, thank you so much. We get 540 for our surface area. So what's very, very important that you need to know, because this is what's going to be on your test, is you need to be able to identify which sides are what you're going to be using for your volume, like what numbers you're going to be using for your volume, and which numbers you're going to be using for your surface area. Those are very important. I've put a lot of shapes that have 4 numbers at least. So all of my shapes have at least that. Because for my rectangular prisms and my triangular prisms, I am going to be asking you for both the volume and the surface area. Each is worth 1 point. So let's talk about this, because I have these conflicting people right here. Exactly. Surface area and then volume. Surface area, if this was feet, it's feet, feet. What would surface area be in? Feet squared or feet cubed? Let's see, because I'm going to say what Gore is. Gore just read it here. Surface area is feet squared. An area, aka volume, is feet cubed. We know that surface area is squared because look, it's a flat shape. You see what I'm saying? When we unfold it, it's a flat shape. Yes, we put it back together. And yes, this is a three-dimensional shape, but we're only caring about the flat portions of it. Are we caring about the inside? No. So surface area is feet squared, volume is feet cubed. Yet again, on the math test, you cannot put the units. So you can't put feet squared, you cannot put feet cubed. It doesn't work. So you can't put it. So just put the numbers. So we've gone over rectangular prisms finding volume and surface area, triangular prisms finding volume and surface area. Now we have one more type of shape. We have pyramids. Now the problem with pyramids is that there's actually two different kinds of pyramids. There's pyramids with a square and or rectangular base, typically square because that's how we know what to do. And then there's pyramids with a triangular base like that. So there's two different kinds of pyramids, and we're going to need to know how to work both of them. When we're finding this, we are not finding the volume of pyramids. We don't know how to do that yet. We do not know how to find the volume of pyramids. All we care about is surface area. Surface area still is adding the area of all sides. Adding the area of all sides. Oh. Hey. So it's always adding the area of all the sides. So the base of this, it's pretty easy. The base is just that bottom square. It's what's touching the bottom. Mind you, you're saying it's not necessarily called the base here because it doesn't have anything parallel, but I'm just calling it that. It's 5 times 5. That's 25. Now, these are all triangles that have the same base and the same height because they each have a side of 5 and a height of 4. So I'm going to have 4, because there's 4 sides, times 1/2 times 5 times 4 again. So the reason that we're doing that is we have 4 different sides. When we have a triangular prism with a square and or rectangle at the bottom, we have 4 sides. And we know we have 4 sides because there's one side for each of, there's one of the sides for each of the sides of the square. Do we see how I just kind of like unfolded my pyramid right there? I just kind of made it look like an unfolded star. So I know there's 4 sides. Again, I'm just going to start cross-canceling things. That becomes 2 times 5 times 4, which gives me a surface area of 40. And it would be 40 centimeters squared. We see that centimeters squared up there, but yet again, on the test, we don't do anything. Here's my other type of pyramid that I have. This one has a triangular base. Since it has a triangular base, besides the base, how many sides do I have then? Yes, I have 3 sides because I've got 1 for each of these sides of the base. Notice I just kind of unfolded that. It's hard to kind of a picture, but I have 1 for each of those triangular sides. So I need to be able to find my base for all of them. So when I care about this, remember, I only care about what makes my right angle. So this is a length of 20, right? And this is a length of 20. And this is a length of 20. Since they're all a length of 20, all 3 of these sides are going to be the exact same. So we're going to have 3 times, and then they're triangles. So it's 1/2 times 20, and since we're talking about these upper sides, times 25, because that's what's called our slant height. You might hear the word slant height. We call it a slant height because it's the height, but it's slanted. It's the exact same thing. We still care about the height and all of that. Once again, I'm going to cross-cancel that out. I get 10. 3 times 10 is 30, times 25 is 750, I think. Yeah, thank you, Caesar. Yeah. So we'd find that. That's just so far the area of those 3 upright sides. But we need to add that base. That base has a side of 20, our right angle, and our length of 17.3. So we just have 20 and 17.3. 20 times 17.3. Perfect. We get 346. We want to add those 2 numbers together. 6, 9, 10. This is just me adding those two together. So my surface area is 10,096 inches squared. Remember on the test, we still don't write inches squared. So that's literally how we find surface area. That's how we find it with our pyramids, regardless of which way. You just have to make sure you know what you're doing. You need to know what numbers you're looking for. Helpful enough on pyramids is they have these, it's going to typically be equilateral. So they're typically going to be equilateral. Now, the last thing I want us to look at, and it's just going to be a different thing, is it's finding the missing dimensions. Here are missing dimension problems. Here, it's saying, what is the width? So we don't know what our width is. We know it's going to be something is equal to width of a rectangular prism. So we know that rectangular prism, we're talking either about surface area or we're talking about volume. We see volume. So volume is length times width times height and or base times height, just so that you know that you can see it both ways. But length times width times height. Now, volume is 1, 1, 2, 3, 2. We don't know our width. We know our length is 13, and we know our height is 36. Now, what is that word I always ask you to do? What is it that I always tell you we need to do? Exactly. We isolate the variable. So here we've got our variable and we're multiplying our variable. So how are we going to isolate the variable? How do we isolate it when our variable is being multiplied by something? Excellent. We divide, says Izzy. We do the opposite of whatever's happening. So if we had width plus 2, we'd do the opposite. To isolate our variable, we'd subtract 2. We spent like 3 chapters doing this, so if you don't know how to isolate a variable now, get out of my classroom. So we want to divide. So we want to divide by this 13 times 36, because then that goes away. So I want to solve for 13 times 36 first, because it'll make my life a little bit easier. So 13 times 36 is 10 times 36, and 3 times 36, which is 360, and then 90, 18, 108. So it would be 468. So I would get 1, 1, 2, 3, 2 is equal to my width times, what did I say, 468? So then I just divide. I literally divide. So when I divide 1, 1, 2, 3, 2 by 468, I get my width to be equal to 24. Yes, Gore, exactly. So our last problem here, we've got a triangular pyramid. So our triangular pyramid has a surface area. So we've got our surface area is equal to 336 square inches. So my surface area of a triangular pyramid is 336. It is made up of equilateral triangles. So they are all the exact same triangle. So if they are equilateral triangles, how many triangles do I have? If they are all equilateral triangles, how many of the same triangle do I have? It's 4, because I've got one triangle, as I erase it all, I've got one triangle here, a triangle in the back, a triangle on the side, and my triangle on the bottom. So I've got 4 triangles. So I know that my surface area is adding up all of my sides. So each side is 1/2 of my length times my slant height. So if my length is 12, then I don't know what my slant height is. I'm going to call it height, and I have 4 triangles. So it's times 4. When I'm lazy, I like to cancel out the biggest things. This becomes 6. So 4 times 6 times h is equal to 336. 4 times 6 is 24. H equals 336. We want to isolate that variable. So because it's multiplying, we are dividing each side by 24. So h, 336 divided by 24 is 14. So the slant height would be 14. So Gore figured this out too, a separate way, and it was really, really smart how Gore did it. He knows that there's 4 triangles and they have a side of 12. So what he did was he divided this one by 4 and then divided it by 12. I don't know how he did it, but it was really smart. He found out that each of our triangles has an area of 84, and we know that our bottom side is 12. So we want to divide our 84 by 12 to find our slant height, but it's half. It's a whole thing, so it would be double. It's a whole thing. Anyway, the easiest way, like I said, surface area is it's our length times our slant height times that 1/2, and then however many sides we have times that 4. So once again, all we ever want to do is we want to isolate that variable. We want to isolate our variables. So I want to find my triangular prism. I have the volume, so we care about volume. Our volume is 6,300, and we know that volume with our triangle is 1/2 length times width times height. It does not matter. Notice how it just says X? It's because it doesn't matter. I'm just going to replace the other two. So I'm going to say my length is my 30, and I'm going to say my width is my 35. I do not care. It doesn't matter which one I plugged it into. It's multiplication. So then I want to multiply these together, and then I divide. This one becomes 15. 15 times 35. 10 times 35 is 350. Half of 350 is 175, I think. So it'd be 5 to 5, which actually makes sense. I believe that's correct. 15 times 35. Yeah! 525. So now what I'm getting is 6,300 is equal to 525 times our height, because we don't know what it is. Once again, we want to isolate our variable. Notice that whenever we're doing multiplication, it's always division. So we divide. We divide that 6,300, and we divide it by 525, and we get our height to be 12. So Gore put 6 because he decided to half it, but we already halved it when we were doing our initial multiplication. So be careful that you don't accidentally do that. If you want to check your work, multiply half times length times width times height, and you should get 6,300. Since you're using your calculator, since you can, there is no excuse for you not to check your work. There is no excuse not to check your work. So literally, all we do with these problems is that we just isolate the variables. So whenever you're doing it, you want to find it out. When we're finding volume, our volume's already isolated because it's going to be our volume equals, let's say, length times width times height. Notice because it's already isolated, we don't have to do anything but solve for it, as opposed to when I had my volume where I have to isolate my variable of h. So that's just the thing that I want you to keep in mind, is that we've already isolated it when we have it as our volume equals. It's just naturally isolated, but we have to isolate it otherwise. And remember, isolate means to get on its own, because if you get put in isolation, that means you're all on your own. Everybody, good luck on your test. Make sure you watch the review video, turn in your homework through Schoology, and you know what to do. If you have any questions, message me, although I might not get back to you instantly. Thank you, and have a great day.